This video is presented by Subi, lecturer from Immanuel Arasar College of Pharmacy. Today we have see about sulfonamide derivatives. Sulfonamide derivatives, this is one of the diuretic drugs. These agents are 5-sulfonyl benzoic acid derivatives. Examples are furosemide, bumetanide, etc. These are two series of 5-sulfonyl benzoic acid derivatives that differ in the nature of the functional groups that can be substituted at second and third positions. 5-sulfonyl 2-amino benzoic acid, example furosemide. 5-sulfonyl 3-amino benzoic acid, example bumetanide. SAR means structural activity relationship. The substance at the first position must be acidic. The carboxyl group provides optimal diuretic activity, but other groups such as tetrazole impart good activity. A sulfonyl group at the position 5 is essential for optimal diuretic activity. The activating group at the fourth position can be chlorine or CF3. CF3 means trifluoromethyl, as in thiazide diuretics. Better activity was observed when these groups have been replaced by phenox, alkoxy, aniline and phenyl moieties. The activating group at the position can be chloride or CF3 as in thiazide diuretics. Better activity was observed when these groups have been replaced by phenoxy, alkoxy, aniline and benzyl moieties. The substitution possible on the 2-amino group in 5-sulfonyl 2-amino benzoic acid derivatives is limited in the order furfuryl, benzyl, thioenyl methyl only. In case of 5-sulfonyl 3-amino benzoic acid, the 3-amino group can be widely substituted without much change in the activity. Next, we have move on non-sulfonamide loop diuretics. Example, ethacryonic acid. Ethacryonic acid is a phenoxyacetic acid derivative, which is the only important member of this class of drugs. This is the structure of the ethacryonic acid. Structural activity relationship. Activating group chlorine or CH3 occupy either the third position or the second and third positions. An acryloyl moiety which reacts with sulfhydryl containing receptor present in renal tissues should be at the para to the oxyacetic acid group. Reduction or epoxidation of the carbon-carbon double bond in the acryloyl moiety yielded compounds with little or not diuretic activity. Side 3 diuretics. Thiazides and thiazide-like diuretics. These agents are 1,2,4 benzothiazine 1,1-dioxide derivatives and are known as thiazides and heterothiazides, lacking double bond at position 3rd and 4th. Thiazide diuretics. First we will see about heterothiazide diuretics. In hydrochlorothiazide Structure having R group is chloride and R1 is H. Hydrobromethicid having R1 is CF3 and R1 is H and R is CF3. Mechanism of action. These block the reabsorption of sodium and thereby the reabsorption of chlorine in the distal convoluted tubules by inhibiting the luminal membrane bound sodium chlorine co-transport system. Adverse effect. Hypersensitivity reactions, hypokalemia, slight reduction in the cardiac output. Users extremely useful in the treatment of edema associated with mild to moderate congestive heart failure. Other uses include hypertension, diabetic insipidus, etc. Structural activity relationship. Substitution at position second with a small alkyl group such as methyl does not change the activity. Substituents at position third determine the potency and duration of action of the thiazides diuretics. Loss of the carbon-carbon double bond between the third and fourth position of the thiazides nucleus increase the potency approximately 3 to 10 folds. Loss of carbon-carbon double bonds between third and fourth position of the thiazides nucleus increase the potency approximately 3 to 10 folds. Direct substitution at 4th, 5th and 8th positions with an alkyl group usually diminishes diuretic activity. Substitution at the 6th position with an activating group is essential for diuretic activity. The best substituents include Cl minus, Br minus, CF3 minus and NO2 minus groups. For example, replacement of 6Cl by 6CF3 does not change potency, whereas replacement with CH3 reduces diuretic activity. The sulfonamide group at the 7 is essential for diuretic activity. The sulfonamide group at the position 7 is essential for diuretic activity. Removal of this group yields compounds with little or no diuretic activity. Side 4 diuretics, potassium sparing diuretics. A negative feature of all the above discussed classes of diuretics is that they increase the renal excretion rate of potassium and can induce hypokalemia. 3 chemically distinct diuretics have emerged that increase sodium and chloride excretion without a concomitant increase in the urinary excretion of potassium. These agents are known as potassium sparing diuretics. The potassium sparing diuretics are divided into 2 groups on the basis of mechanism of action. Sodium channel inhibitors, example triamtrene and amiloride. Aldosterone antagonist, example spironolactone. Sodium channel inhibitors. Mechanism of action. Amiloride and triamtrene inhibit the sodium channel in the luminal membrane of collecting tubule and collecting duct. Amiloride and triamtrene inhibit the sodium channel in the luminal membrane of collecting tubule and collecting duct. Inhibition of the sodium channel does not only inhibit sodium reabsorption but also inhibits secretion of potassium and hydrogen, resulting in conservation of potassium and hydrogen. Triamtrene is an aminopteridine derivative and has a structural resemblance to folic acid, whereas amloride is a pyrazinoquinidine derivative. Amloride is a pyrazinoquinidine derivative. Aldosterone antagonist. Spironolactone is the only available aldosterone antagonist. A metabolite of spironolactone, canreninone, is also active. Spironolactone is steroidal derivative structurally related to progesterone. Mechanism of action. Aldosterone, by binding to its receptor, enhances the passage of sodium from the luminal fluid into tubular cells. Sodium reabsorption and the passage of intracellular potassium into the luminal fluid at site 4. Spironolactone competitively inhibits binding of aldosterone to its receptor and abolishes its biological effects. Aldosterone, by binding to its receptor enhances the passage of sodium from the luminal fluid into the tubular cells. Sodium reabsorption and the passage of intracellular potassium into the luminal fluid at site 4. Spironolactone competitively inhibits binding of aldosterone to its receptor and abolishes its biological effects. This is the structure of spironolactone and canreninone. Canreninone is a major active metabolite. It is one of the major active metabolite. Okay. Today class is over. See you next class. Thank you.